Probably most YouTubers who have been looking for batteries, for lithium ion batteries specifically, and for 18650 batteries in particular, you probably recognize this. Like about, I would guess maybe a billion other people on YouTube. I got inspired by some of the Powerwall people and started collecting 18650 batteries of my own. This is part of my collection. These are the ones that are less than 1800 milliamp hours, and those happen to be the bulk of whatever I've been able to collect. I guess other people have had better luck than I have. I started collecting these 18650 batteries mainly just to see what the sources were around the area that I live in, and they're not real plentiful. I never had in mind that I was going to do a power wall like Pete in Australia or Jehu in California. I always thought that I would just collect enough to do small projects. Okay, here's the golf cart. I bought this bag from the company that made the golf cart just so that it would fit on it better, because the one I had was too short for the cart itself. This model they don't make anymore. I don't think they've made it in years. The one thing I hate about this golf cart is the MMI, the interface that you have to use for this thing. You've got a button here that turns it on and off. You've got a knob here you can turn to run it manually. And you've got an LED here that represents battery. And you'll notice it says normal, weak. So the battery goes from green to red. The LED goes from green to red when the battery's discharged. And it's pretty far down by the time that thing goes red. The motors are they're 800 watt motors each one. So if you do the math at 12 volts, these motors can take up to 30 amps. That freaked me out. But anyway, there it is in all its glory. I got it secondhand for $100. They normally retail back when they were selling for about $800–900. Here's my golf cart in action. I used to have a push cart, but I got tired of that, and I got this pretty cheap from a guy, so really grown to like it a lot. It really only has two issues. One is that it pulls hard to the left, especially on grass. And the second one is that the wheel, the front wheel that is, needs to stay on the ground better than it does, which means I have to put weight in the front. That's about it. When I bought my electric golf cart from this company, Cart Tech, the battery that was there with it was pretty much dead, so I went out and got another lead acid battery. You can see I put a little shunt resistor on this one and ran it for a while, and it runs fine. There's nothing wrong with this. It's a lead acid battery and it behaves like a lead acid battery. It doesn't have much depth of charge. It's good for 9 holes, and that's about it. I have taken it 18, but it ran it way down. It uses this Canon type connector to provide power to the cart, and everything was fine. The battery weighs 21 pounds. But I thought how cool it would be to maybe build a battery myself using 18650s. And so what I did was put together a 14.4 volt battery and using the 18650s, and it puts out about as much power, I mean it has about as much capacity in these two little bundles that weigh 6 pounds as this big hulking guy here that weighs 21 pounds. So this is what's going to go in the golf cart. Okay, I'm very excited to announce that I have my lithium-ion battery pack pretty much ready to go. It's pretty ugly. You can tell this is not commercially made, but everything's wired in. I 3D printed this little control panel here, and you'll notice right here I've got the remote control connection that I'm going to develop. Right now I've just got it hooked up so that I can turn on the battery pack using this relay right here. So what I'll do is I'll just clip this clip on here. Oh, you can hear it clicking on and off. That's not good. Let's go around here. Note the nice blinking green light. Normal operation. Hold this button down until the light goes solid. There you go. And now let's see if we can get this thing running. Get the remote controller here. Oh, look at that. Faster, faster. Yeah. This remote has its problems, I think, sometimes. These buttons, they're pretty cheap. There's position 2. 3. 4. Oh my gosh. We'd be flying. Here's the control box that I'm working on. This little box right here. This will provide power to the cart, which I wanted because sometimes the cart screws up and the only way to fix it, I think it's a little computer up in the controller. The only way to fix it is to pull the power plug completely, and I'm not about to do that. This plug right here, I'd just soon leave that in there. So here's the box that everything's coming in, the control cable. It's going to use the Arduino Nano microprocessor, and here's the motherboard. I got a little DC buck converter to convert the 16 volts down to 6.25, which goes to the VN of this thing. This guy puts out a 5 volt signal, which goes down to, through this plug, to the controller here. You can see all the jazz going on back here. I've got the current sensor back here, a number of other things. This right here is the display. It's a Nokia 5110. I have to wire it in yet. But when it's all said and done, I'll have voltage, current, temperature of the battery pack, and of course other things that all you have to do is calculate, like amp hours, state of charge and things like that, which I'll have displayed. You saw a little bit of the testing that I did on the golf cart itself, and I wanted to kind of just go over a little bit of the details. It's a 4S 15P battery, 29 amp hours. Ew. Notice the flashlight with my name on it. That's a nod to one of my favorite geeks on YouTube, Julian Eilert, who has a flashlight with his name on it, so not to be outdone. Anyway, I got this thing running, and I took it out on the golf course, and it had 16.4 volts when I began my 9-hole round. After around 3.5 miles of pulling my huge bag around the golf course, it measured 16.1 volts. So this battery is going to easily handle the job. I wanted to show you one other thing. I couldn't decide on the fusing on this thing, what to do. So I've got some 35 gauge wire here, and on the other side of the pack I've got 1/8 watt resistor wire. I don't know if we can see it over here. This is 35 over here as well. I'm going to hook it up and show you the display here next. Okay, here we are. I have over here a dummy load. Pull about maybe 1.5 amps, 2 amps of current. I have my display set up here with some industrial Velcro on it that hooks onto the golf cart. I have the length of wire, which is way too long, that runs down to the battery pack on the DB9 connector. The battery is cut off from the load by this relay, as I've mentioned previously. And the switch on the side of the controller actually cuts the battery on, and then the battery voltage is fed back up to the display. And the nano inside there kicks on. So let's take a look at that. There you go. I stole a lot of code from Adam Welch's project. Of course, not all, because this is different, but using the Nokia display and whatnot is something I stole from Adam Welch. Thank you, Adam. Appreciate it. So that's it. It reads out the voltage. It reads out the current in large letters. I took it out on the golf course, and I had those small letters. I couldn't read the thing with it bouncing around. And I have a thermistor embedded deep into this battery pack so that we could measure. I don't know if you can see, it goes in right there, deep down into the battery pack, and I can measure the temperature. And it's currently 62 degrees here in my man cave. That's it. It works great. I love it. I sent a little report to the manufacturer of the cart, because he warned me not to use a 16-volt battery in a 12-volt setup, and I was a little leery about it, but I did it anyway. And the motors just seem to love it. They just go crazy. That golf cart really hauls. I'm going to have to recalibrate it for my walking speed. Anyway, there's a little look at that.